Good day, grade 10 students. Take a look at the image that you have in front of you. A lens can actually flip an image upside down. Now, why is that? That's a very important question. Well, first of all, the type of lens that we're using is known as a convex lens. And a convex lens will take the light rays and will focus it on a focal point. Now, this is interesting because we've used the term focal point before. Now, why is that? Well, it's because of a special thing that we just learned about, known as refraction. Now, refraction means that things will, when they go through a more optically dense substance, they'll move towards the normal. Now, it's interesting because this causes images actually to flip upside down. As the light gets bent, the bottom gets bent up and the top gets bent down, and so therefore the image is upside down. Now, it's kind of cool because we have lenses inside our eyes, and we're going to talk about this more, but it actually flips images upside down. So let's talk about optics, refraction, and lenses. We have two types of lenses. One is known as a convex lens, and the other one is known as a concave lens. But unlike lenses that, unlike mirrors, a convex lens will actually converge the light rays, where a concave lens or diverging lens will actually divert the light rays away from each other. So convex, parallel lights come in and it converges towards a focus. Concave lens, on the other hand, parallel rays diverge from each other. You can use these in a lot of different manners. For example, convex lenses can be used in magnifying glass. They also can be used in normal glasses, whereas concave lenses can be used as flashlights or headlights or other purposes as well. So we need to know some basic terminology, both for convex lens and concave lenses. So the main line through the middle is known as the principal axis. You want to write this down. You have the object. You have something that's the primary focus. That's where the light rays will focus on a convex lens or converging lens. And you have a secondary focus, which is in the front. In a concave lens, what you have is the same principle. Principal axis, object, primary focus, and secondary focus. So the secondary and primary are actually flipped when you're talking about the focuses. They're opposite. So in a convex lens, the primary focus is going to be on the opposite side. When we draw diagrams, we're going to understand why this is. So how do we find an image in a convex lens? Well, the first thing that we got to remember is if we draw a straight line from the top of our object that is parallel, that's a key word, parallel, it goes through the focus. Instead of the focal point, we're going to call it a focus in a lens. So let's take a look. Light ray goes parallel, goes through the primary focus. Next, we got our second rule, which is going to be the opposite of that. If you go through the focus, in this case the secondary focus, the focus in the front, it's going to end up going parallel. Take a look. Focus, parallel. At this point, we can actually form our image because we just need two light rays crossing to form our image. This is where the top of our arrow is going to be, and it's actually going to be upside down. To double check this, we can draw a third line, and that goes through the optical center. The optical center is similar to the C on a mirror, but the light ray just keeps going straight through. Because remember, lenses, the light rays just keep going and don't change. So this is where our image will form. So finally, the top of the image is located at the intersection of your light rays and after they've been refracted. And remember, you only need two of these lines to locate an image. And our image is going to be right there. Now, what about the salt of this image? You can go through it and you can take a look and you can argue that it is inverted, the attitude. The location is on the opposite side of the lens. The type is it is going to be a real image, and we'll talk about why that is. And the size, it looks to me that it's a tiny bit smaller. Okay, so again, salt is the same. So real images are behind the lens as opposed to mirrors as well. So finding an image. And we have those rules for a convex lens. So how do we find an image for a concave lens? Well, let's take a look at this. This is a diverging mirror or concave lens. And the rules are going to be similar, but they're going to be a little bit different here. So the first rule is we draw a straight line from the top of the object, parallel to the principal axis, except now it goes through the primary focus. Remember that the light ray will actually move away. It's not focusing light rays, it's moving away. Now, if you're like, well, that wasn't lined up with any focus, but if we draw a line back, we can see that it goes through that focus, which is in the front. Now, we can draw a straight line from the top of the object towards the secondary focus, and then from that point it will refract the light ray through the lens parallel to the principal axis. Let me show you what I mean. So we go through the other focal point, or towards it, and then it bounces parallel to the principal axis. This one's going to be a little bit tricky to remember, but it's similar to that. So where do the light rays cross? Well, you remember they're actually crossing as dotted lines. And this means that we're going to actually get sort of a virtual image, which we'll talk about. Finally, the top of the image is located at the intersection point of your light rays after they've been extended into the virtual area. So we have a virtual image right there, and you can see it. So what is the result of this image? Well, we can describe it. It's virtual because it's in front. It's in front of the lens. It is upright, and we're going to say that it is smaller. So let's briefly talk about the eye. The eye is quite amazing, and if you notice, if you look into the center of this image, you'll see that there's a lens inside your own eye. And that lens actually bends light. And when it bends light, it actually flips the image upside down. So if your cornea bends the light just ever so slightly, it hits the lens, and then that convex lens, which is a converging lens, flips the image upside down onto your retina. Now that travels along your optical nerve, and when it travels along your optical nerve, it actually flips it back right side up when it's in your brain. So your brain is actually flipping the image upside down. The shape of your eye is actually really, really important. In normal vision, the light rays actually focus on a focal point at the back of your head. Now, if you have a nearsighted eye, that means your eye is too big. So what happens is the light rays will travel into your eye, but won't hit exactly at the back of your eye. The focal point is actually too far forward. So if you're nearsighted, your eye is too long, the focal point's too far forward, it's difficult to see things that are farther away. And as a result, what we can do to fix this is we can use a concave lens. Concave lens will adjust the focal point and force that light to hit the back of your eye. It will actually cause it to diverge just a little bit, and so it hits at the back of your eye. The other type of eye that you have is a farsighted eye, which is too short, and the light rays are actually hitting behind your eye. So if you're farsighted, your eyes, sorry guys, are too short. So you can use a convex lens, and actually will focus that light closer to your eye. And that's how we solve those problems. So that's the relationship between light and your eye. Then our